look at this example. In this system, I have two processes G1, G2. These two processes are connected in parallel. And before that I have final control element having transfer function GV, and there is controller transfer function GC, and this for whole system I have a feedback transfer function H and connected back to the summing point. Now input is X and output is Y. I need to find the overall transfer function of this process using block diagram reduction technique. Now if you look at this system block diagram, we can say there are two summing points. In any block diagram problem, we need to eliminate summing points one by one from inside to outside. See what are the internal summing points that are available, try to reduce them using the formulas given, and then after you come to the final summing point. Now, so it is very easy, we can say your G1, G2 both are connected in parallel, therefore I can add them. It results in G1 plus G2. Now GC, GV, G1 plus G2 all are connected in cascaded, we can multiply them. So once you multiply, you will get GC, GV into G1 plus G2, and feedback of course we have H. So now it is coming to our closed loop block diagram where I have G and H. The G is nothing but GC, GV into G1 plus G2, and I can use that loop formula where for negative loop we have G by 1 plus GH, and it can be reduced into finally GC, GV into G1 plus G2 divided by 1 plus H GC, GV into G1 plus G2. So which is the overall transfer function of the given system. Let us take another example. In this example, there are three processes G1, G2, G3, where using G1, G2 I have internal loop, and after that G3 is cascaded, and before that we have a controller KC and a feedback transfer function is H. I want to find the overall transfer function of this system, which is Y of S by X of S using block diagram reduction technique. Now it looks very simple because already I have one internal loop, I can reduce it, which is a negative feedback. So it gives us G1 by 1 plus G1, G2. And now all three are in cascaded, I can multiply them. So that it results KC into G1, G3, that is G, and H is already H. So again if you use G by 1 plus GH formula, the loop formula, then the final transfer function is Y of S by X of S KC G1 G3 divided by 1 plus G1 G2 plus KC G1 G3 H, which is the overall transfer function of this process system. Now we'll try to increase the complexity in the block diagram problems. So here I have two individual loops, and one loop I have G1 G2 H1 and another loop G3 G4 H2, but these two loops are interrelated with H3 feedback. That means the output of G3 is given back to your input of G2, which is interconnected between these two loops. So whenever you have this kind of problem, then we need to look at how many summing points are there, what are the internal summing point, and how to reduce them using the available block diagram rules. Now in this case, after G3 we have takeoff point. So this takeoff point can be moved after G4. So any block diagram problem, there is no unique way of solution. You can make any change in this using the rules, only we need to stick to the rules. Means I can change the second summing point, or I can change the third summing point, I can move any takeoff point by using the rules. But simplest way in this problem is to move the takeoff point after G3 then after the G4. So whenever you move a takeoff point after the block, for the same branch we need to add one more block, and that block transfer function will be 1 by G. In this case it is G4, therefore, so we will have after changing H3 by G4 extra, and remaining things are same. And of course we moved our takeoff point after G4. Now if we look at this stage, G3, G4 and cascaded, and H3 is feedback, and we can simplify it as G3, G4 divided by 1 plus G3, G4, H2. Therefore I can eliminate the third summing point. So if you eliminate the third summing point, it is G3, G4 by 1 plus G3, G4, H2. So after eliminating, so this is what my block diagram is after simplifying that. So again, there are different ways to do again. So the second summing point can be shifted before G1 and I can interchange, then I can solve the problem. Or after G2 I have one takeoff point, I can move after the last block, then I can solve the problem. So either way you can do it. So let us shift the takeoff point after the last block, that is G3, G4 by 1 plus G3, G4, H2. So if we move it, again we know the rule, whenever you move or shift the takeoff point after the block, so we should get 1 by G to the respective branch. So if you do that, so you are getting like in a feedback, you are getting a big transfer function, that is H1 into 1 plus G3, G4, H2 divided by G3, G4, which is the feedback. Now in the top of that we have G2, and also we have G3, G4 divided by 1 plus G3, G4, H2. Since these two are in cascaded, I can multiply them. Then there is one internal loop here. That loop can be combined and reduced to in a single block, and again that can be multiplied with a Z1. Then again I have another loop, so we can simplify in this way. So if you do that, you will get something like this, G1, and this block is your G2, G3, G4 and 1 plus G3, G4, H2 plus G2, G3, H3, and G1 can be multiplied here. And the feedback is as it is, whatever we got, the feedback is as it is, that is H1 into 1 plus G3, G4, H2 divided by G3, G4. Now I can reduce this into a single block and I can find out the overall transfer function. So if you find the overall transfer function, then you will get your numerator is G1, G2, G3, G4 divided by 1 plus G3, G4, H2 plus G2, G3, H3 plus G1, G2, H1 plus G1, G2, G3, G4, H1, H2. So this is the overall transfer function of the two loop problem where we have some interconnection. So this way we can solve the problems.